Welcome back, students. In this video, we will discuss about resistance. In the last video, we discussed about conductors, insulators, and resistors. This video will deep dive more into the concept of resistors and resistance. So we will see what is resistance, the property resistivity, the typical value of resistivity for different materials, that is for conductors, insulators, and resistors, and we'll touch upon fixed and variable resistance. So the idea of resistance is opposition to the flow of current. See, current is produced by the motion of electrons within a conductor. When you restrict the motion of these electrons, that is when there are lesser free electrons, then the current is restricted. You are basically reducing the flow of current. So that is called as resistance. The SI unit of this property or this resistance is ohms. So in the next video we will discuss, in the next video we will discuss about Ohm's law. So there you will understand much more about resistance. So there are two types of resistance, fixed and variable resistance. A variable resistor is called as a rheostat. So what are the factors affecting a resistance? Say you have a current carrying conductor in your hand, let it be a copper wire or a aluminum wire. So the resistance to flow of current largely depends upon the geometry and the material property of the resistivity. It's called as resistivity. So resistance depend upon geometry and the material of the resistor R is equal to rho into L by A. A is the area of cross section of your wire. L is the length of the wire. And rho is the resistivity, which we will check now in the next slide. So the geometry, whatever I talk about geometry, this is more to do with the area and cross-sectional area and length. See, in the case of wire, you'll have a circular wire which will have a diameter. With the help of that, you can calculate the area, and length is whether it's a 1 meter wire or a 2 meter wire. This apart, resistance also depends upon temperature. It is directly proportional, means when the temperature rises, the resistance also rises. Similarly, the other three properties, resistivity, length, area, they are in some way proportional to the resistance. The resistivity is directly proportional to R, which means increased resistivity, increase in resistance. Length is also directly proportional. You increase the length, the resistance also increases. But whereas area is inversely proportional. Area is inversely proportional means if the area is increased, the resistance decreases because it is on the denominator. And the fourth factor is the temperature. So we saw about resistivity. See, resistivity is the property of the material, that is where you have a wire, copper wire or a aluminum or a silver wire. Each material has a resistivity. So that property is what opposes the flow of current at a temperature and pressure. The SI unit of resistivity is ohm meter. Okay. Resistive range. So what can be the typical values for a good conductor, like whatever we saw, the copper, aluminum, silver, they have very low resistance. So they have the range of 10 power minus 6 to 10 power minus 8. So you can notice this value of minus 8 or minus 6. You can imagine how low the resistance is. I'm talking about the value of rho for all these kind of materials. On the other extreme, when you have a kind of insulator, that's what I call as a bad conductor, the resistance is very high, 10 power 10 to 10 power 17 ohm meter. You can just imagine the kind of positive value. If you expand it, it's 1 followed by 10 zeros. So that is the amount of resistivity these material have, and due to that they don't conduct electricity. So this picture is from your textbook. So you have the values, different values. You need not memorize these values, but you just can see the range. The conductors are all have somewhere between 10 power minus 8 to 10 power minus 6. So all these have good conductors of electricity. On the other end, insulators. Insulators like glass, all this have somewhere between 10 power 10 to 10 power even 17. So they make very poor conductors of electricity, but they are very suitable for being a insulator. So in between conductor and electricity comes resistors. The resistors we discussed in the previous video when we discussed about conductors, insulators and resistors. These are artificially made or designed to be what to say, designed as resistors by mixing some two metals and forming alloys. So you can see the resistivity in these cases ranges from 10 power minus 6. It is in between, actually it is in between conductors and insulators. So resistors are designed from uh, like they are not pure metals, they are two or three metals which are mixed to create resistor materials. So as I told you, there are two kinds of resistance, fixed and variable resistance. These are the kinds of fixed resistors what you see. So whatever I'm going to say now is more of an academic interest, not of academic interest, but more of a just a knowledge, additional knowledge, good to know. So you see some color codes, like I don't know whether it is a 5000 ohms or 50 ohms or 5 ohms resistor. I don't know anything about this. So these color codes give some hint about the value of resistance. So these are the color codes, whatever you see here. So yellow, the first color is the first digit, second color is the second digit, third color is the multiplier. Multiplier means 10 power 3 or 1000 or whatever. And the tolerance. Tolerance means there is always a manufacturing error. It is not exactly 5000 ohms. It could be 4995 ohms or 5005 ohms. So some amount of variation will be there. So that is the fourth digit or the fourth color stands for. So for example, the given one, violet for violet stands for 4. Yellow stands for 4. The first digit, yellow stands for 4. The violet stands for 7. So 7 comes here. And the multiplier red stands for 100. So the 100 comes here. So tolerance you can ignore. It's either gold or silver. So the resistance what you have or resistance is 4700 plus or minus 5% error. So 4500, 4700 ohms. So like this, by having this resistance, over experience, a electrician will be able to identify what is the value of a resistance for a particular resistor. So this is how resistors are arranged in a circuit board. This is all to limit the current that is flowing to the flowing through the circuit board. You can see the resistance. Whatever you see here, these are all the resistances which are embedded in the circuit board. These circuit boards you would have seen in your laptops, televisions, mobiles, all the electronic gadgets. So these are the fixed resistance. Now comes variable resistance. The earlier image, whatever you saw, it's always fixed. It's 4700 ohms, 4700 ohms. That's it. You neither cannot increase it or decrease it. Whereas variable resistance, it's kind of a mechanical device. You can see the arrangement here. And you can see the terminals where wires can be connected. You can see the red terminal, black terminal. There is a significance for red and black, which we will discuss in the domestic circuits in the magnetism chapter. So we not discuss that now. So there is a significance for this connections. So here's where you connect your positives, negatives, and when you slide this part, one extreme of the rheostat will be zero resistance, and at the other extreme, when you start sliding slowly from one end to another end, the resistance varies. So one end you have the highest resistance, the other end you have zero resistance. So this is called the variable resistance. So in our next video, we'll close with this and we'll discuss about connecting the resistors in series and parallel as well as its significance. Thank you and bye till then.